Hello there, welcome back after the weekend. How are you doing today? I hope you had plenty of rest. Partied hard over the weekend. Thanks for joining me today. We're coming back to building Chordie. We haven't finished yet, plenty of work to do. But before we start, I will give some time, maybe someone will join. And in the meantime, I would like to show you what I have done with the Chordie, since I said that we need to redesign the right part and build it. Well, that wasn't that much of a redesign because it hasn't really changed much, but I added some additional holes and I had to deal with the part that is the actual attachment for Chordie. So okay, this is the bottom part. It doesn't bother us this time. Alrighty, infrared sockets for the switches, and alright, so okay, I think I would need to change something over here, but maybe not now. Okay, let's leave it at chalk. And over here we have extensions. So far we only did this one, which is the left side. Volume is on the left side. And over the weekend I managed to create the trackball, which looks like this. So this time around I decided to fill these spaces over here, because originally that was something like the volume. There was empty space over here, but now it's all fully enclosed. I think this is actually a bit better, since there isn't that much space over here and it won't be visible anyway, because there will be switches covering it anyway. So this is how it looks like with the trackball. And of course we have the touchpad, which looks like this. This one is a little bit okay, I think we have, yeah, so for the chalk switches we have to, for the MX, sorry, it has to be a little bit taller, because from my initial testing I realized that the top of the touchpad has to be aligned with the top of the switch. So when you're like swiping left and right and you do like a longer swipe, you won't really touch the key switch, I mean the keycap. Where is it? I think I have mock-up somewhere over here as well. Yeah, so this is MX socket keycap over here. So as you can see, the top of the touchpad is aligned with the switch. And maybe we could do it maybe like minus 2.4 or something like that. I will see how it goes. I will be definitely building one more prototype just to check it out. But I think my current design, which I don't have over here, I have the one with the touchpad at work. This one has the touchpad at the same level as the top of the keycap. So this is how it looks like. We will be building the right side as well very soon, hopefully. And yeah, I think in terms of CAD that will be all today. As promised, no more CAD for the couple more streams. I guess we can jump to the workbench. Alrighty. So on Friday we finished soldering all the switches, and based on our initial testing they all work. There is a good connection. Also looking at it like this, it's not that really crowded over here. I was expecting it will get much worse, but so far so good. So what we need to do today, we will have to connect this encoder, which is volume, over here. Over here we have a new version of our horizontal encoder, which I have already printed out. I have the wheel over here. This is the right side of Chordie that we'll be building next. Okay. And this is the rest of our encoder. So this is basically the encoder holder. As I said, we're gonna ditch the push button. So this version is without push button. There is no space for push button anymore. Since we don't even have a way to connect it, that is okay. I have two versions designed, and I'm slowly working on a GitHub repo to make this available to everyone, hopefully soon. And over here we have this locking mechanism. I already showed you last time that there's a hole over here and the whole thing fits very nicely. Alright, so which one should we go first? I think first we'll need to check on the diagram. Okay, I think I forgot where did I put the Draw.io. Draw.io. This is very nice program. Okay, I prefer it white. I think I have it saved somewhere. Okay, we are saved. Alright, so we are working on the left side right now. So we have all the switches done. So B7, B6. Okay, so it looks like the next one is B5, which will be our infrared. So I guess we will follow this path. We're gonna do the infrared, and looking at the diagram, I can see that next one is horizontal encoder, and the last one will be volume. So okay, that is fine with me. All right. So I have infrared diodes over here. Okay, we're gonna be needing some resistors as well. Okay, so it happens that I have 68 ohm resistors over here. So we're gonna be needing this resistor as like the limiting resistor because we're gonna pair it together with this. Or maybe I was aiming for the different. I think I might have been aiming for this instead of this one, because there are two types of these potentiometers. Yeah, I think I was meaning to use this one. So I can take this leg out. I didn't even check if it's gonna fit. It fits, okay. Let's take a look if we can attach the bottom plate. Okay, this one also fits. So I guess we can stick to this one. Should be okay, probably. We still have a good access with the screwdriver from here. So if you want to adjust the sensitivity of the diode, we can do it this way. This is already checked idea. I did it on 3i2C, actually on this keyboard that you just saw today. So this thing works, although there we had to do some dirty work because these were not really, the PCB wasn't really designed with potentiometers in mind, so I had to like hot glue the whole thing, but it was okay, it works. Alright, so this looks kind of promising, should be easy, hopefully it will be easier than the previous ones, based on the experience that I had building all other Chordies. I think I did some good changes to the overall design to make it as easy to build as possible. Okay, so the potentiometer goes here, but over here there is a tiny opening for the resistor and there are holes for the resistor legs, so we have to pull it like this, and I think I was having some issues with that. And now when I think about it, I think my idea was to get rid of these and just use the soldering iron to just push the leg through this wall. Okay, we see how it goes. Maybe we'll be able to push it through. I think pushing it through instead of soldering it in or like melting it into the plastic would be better, just in case we need to change something later on. Alright, so let's take a look on the design, because there is one more thing that we need to be aware of. Oh yeah, right, so we need to remember about this resistor. So we have to pull it up to VCC on one end, and that will be for the phototransistor. And for the diode we have to use this one 670, because that was like the old days when I thought that would be okay, but it turned out that it doesn't really work all the time. Like this value doesn't always work okay, so that's why I have a potentiometer now. So I should have no issues getting the exact sensitivity from the diode. Okay, so we have these two resistors, one 10K, so I need to find 10K as well. Okay, and would be also handy to have a data sheet for this thing, just to remember what is what. Yeah, okay, so this is our plus, and this is our plus, our VCC, and this is the ground over here. Yeah, so we need to push the diode somehow and attach the wires to it. Okay, so I think we have everything we need, except for the resistor. We have 68 ohm over here. Okay, 10K. It looks like I had all of them very close, because I think they come from the previous build. I think it says 10K. Maybe let's check it first. Yeah, indeed, 10K. All right. Okay, so I think what we can do, because we need to go from VCC. So as you can see, this VCC wire will come handy, because we'll have a lot of connections from here. So one connection will be going from here to the potentiometer, to this leg. I think we can maybe fit in the resistor over here somewhere. And then from the middle one, we have to go all the way to here. We have to put this resistor over here, connect, and this one will be going to the infrared diode, to the anode of the diode. So we'll have to connect this one over here, and then from the phototransistor, it should be rather easy. Ah, no, wait, okay, I got it wrong. Yeah, I was thinking about something else. So yeah, 10K resistor is for the phototransistor, so not over here. The 10K one, I think we have to put either here or here, doesn't matter. And then we have to, okay, 68 will go here. So for example, 10K will go here, and you have to connect to VCC over here, and then we'll have to connect to the collector of the phototransistor, which will be over here, let's say. Yeah, I think it makes sense to keep 10K on top, and the transistor will be the upper hole on this one. And over here will be the diode, and the diode will have one input going to the 68 ohm resistor to here, and this resistor will be connecting to this potentiometer, and this will be connecting to VCC as well. So that will be VCC for the photodiode. Then the minus or ground from the photodiode will go here, minus from the phototransistor will go as well over here somewhere. We have a lot of ground wires everywhere around, so we can connect no problem. And then from the phototransistor there will be one more wire. This one over here. So from this would be from VCC, we connect over here. So this is our pull-up, and after this resistor, it will go to the collector, and one more wire will go. Well, in our case, it will be B5 because we have changed the design right now. Okay, so I think it's more or less fine. All right, now let's go. Let's start with the 10K. Okay, now when I look at it, I'm thinking I can either push it with long legs, or maybe I should just trim those legs. I'm gonna trim them anyway. Okay, so 10K sits nicely. And what I like to do, oh, actually we need to do it. We have to kind of wrap it around. Definitely we need to trim it a little. I think doing the infrared diodes, I think it's my least favorite part. I don't know why. Okay, I hope that will be enough to hold it. So we have this nice, like a hook. Okay, so this is one resistor. Now let's take the 68 one, and this one goes to the bottom. I think I'm gonna trim it. Like half length at least. Okay, let's see if they don't move too much, so like one isn't touching another. Okay, looks to be safe. So we have no other wires in the vicinity, so it should be okay. Okay, so what we can do now, we can in theory hook up this one to this, because that will be okay, and VCC somewhere. So maybe we can do VCC on the bottom. Yeah, VCC on the bottom maybe, and the resistor will go here. So from this potentiometer we have to move all the way to here and attach it, and then from here we'll go straight to the infrared diode, and the VCC will come from here. Okay, looks easy. Can't really mess that up until I do. Okay, what I like is that the potentiometer, it sits very tight. It's not moving too much, so I don't really need to do any special way to hold it in place. It doesn't need glue or doesn't need anything. It holds quite okay. I did it some time ago, so it was kind of already job done. Yeah, but seems to be okay. And this one is up to 10k as well. So of course, if you go all the way to 10k, it's too much. The diode will stop working. Well, I think it was more or less about like 300, between maybe 150 to 300-400 ohm. It's like a good range. Okay, so I think we can try to solder something. Okay, how much wire do we need? Maybe let's start with the VCC, so that will be something short. Maybe like this. And one side we need to strip quite long, because we have to wrap it around this VCC, kind of a bus, I could call it maybe. And the other side will be rather short, just to connect to the potentiometer. So maybe one side I will strip like this long. Should be enough. And the other side a little bit short. I don't really need too much. So one side is like this, and the other side is like this. Should be good. Okay, should be okay. Not too much, not too little. Yeah, so we have something like this. Okay, so far so good. It's getting a little bit crowded over here because we still have to connect I2C bus, SCL and SDA. But we can move those wires, so no problem. Just for the time when we need to do the actual soldering. Okay, so now from here we need to move all the way to here. So maybe to avoid clutter over here, I could maybe go around. I think I can solder it here and we can go through here, around maybe the top spot and come down from here and connect to this one. So we have some more space over here. Okay, for this one we don't really need to strip too long. Although on the resistor side, maybe we can go a little bit longer because then we will be able to wrap it around just like on the VCC bus. So it should hold a little bit better because then we'll be... this one is... Okay, so for this one I don't think we'll be soldering anything else, but on the transistor side, I think it would be better to just wrap it around because there will be one more wire going from the collector to the I2C expander. So that will be like a 2-point connection. So we're gonna wrap it first, then wrap the another one and only solder at the end. See how it goes when we get there. Okay, so as I said, this one will be on top. It might maybe make sense to bend this leg a little down. Okay, like so. Okay, not the finest soldering, but I think it should be fine. Okay, I think I stripped it too early. Because it's gonna be a little bit difficult now to move it around with this exposed wire, or maybe exposed core. Okay, maybe I will just go on the other side, like this. All right. Okay, so we are definitely too far, too much wire. So I guess I have to strip it a little. Maybe if I cut it like where the resistor starts, so maybe over here somewhere. It seems like wrapping it around is not that easy task. Okay, I guess I'm gonna just solder it and just chop off the remaining part. Oh, hey, SG District Homes. How are you doing today? How's the music in the background? Not too loud? Not too loud? Or maybe not loud enough? Okay, so we went from here all the way to here. Okay, so next thing, let's do 10K. Let's hook it up to VCC. And we can also do from here, okay, because okay, this leg will go to VCC. This leg one input will go to B5, and another one will go to the phototransistor, because that will be the collector of phototransistor. So we have to remember to put the collector on the inside and the anode on the inside as well. No sound? You mean you can't hear me? So you can't hear me at all? Oh, that is odd. Everything should be fine. Okay, let me do a quick sound check. Okay, so you can't hear me, only the music. That is odd. Okay, how about now? Should be okay, I suppose. Okay, how is it now? Okay, I think the sound is in. Okay, I guess I will have to post another stream on the videos. Kind of disappointing. Okay, where were we? So VCC, okay, so VCC for the 10K resistor. So okay, cool. Well, I did change the output, but I don't know why. Yeah, I know because I checked myself. I don't know why it's like that. Should be both. Something's wrong with the settings as usual. Talk again. What do you mean? Yeah, I think now is okay. I checked my stream just now and I could hear myself. Yeah. Oh well. Happens. Especially when you do 5 minutes fix up before the stream. Okay, anyways, let's continue with wiring this stuff. Can you hear the music as well at this point? Both my voice and the music? Well, I should have went somehow around, but okay, anyway. Alright, let's fix this one up because it's a little bit too loose. Okay, so one more. Yeah, I said we need to do it the other way, like connect first those two wires and then solder it. But I already soldered one, so I guess we have to stick with that. Now we're gonna be needing a short wire because from here, actually from the bottom. Oh no, sorry, so that is correct. So that was VCC, so we don't need to connect anything more. We have to do it from the bottom one. So this one will go to B5. So not everything is lost yet with this wire. No, I don't really need it this long. Yeah, I think we can trim it quite a lot even. Alright. So A5 is done. So now we have to take care of the diode. Okay. Alrighty, I hope there is audio right now. Also on this microphone. Alrighty, so going back to the schematics. Alright, so we have the diode. It looks more or less like this. So this is our top view. So the top part, this is our ground, which is we can actually route it together. And the top, oh no, sorry, wrong. So the top part, looking at it right now. Okay, looking at it like this. So these two legs on top, this is collector and anode, which is our plus, and the bottom is minus, or ground. So it should be easy to remember because, like, when you look at it, the bevel shaped side, so to the right, so then the bottom should be minus. Although I did it so many times, I can never remember which one is what. I always have to check. Okay, so how I like to do it is I trim the bottom legs for the ground. I cut them shorter than the positive ones. So how much space do we have over here? Yeah, so doesn't have to be super short. Let's see if we do it like this. Okay, so after trimming, it looks more or less like this. So the top, which is this part, so that is the top, longer legs. This is our positive ones, and the bottom is the ground. So now we have to push it out from this. I need to check which one was where. Okay. So this one, the blue one, is the diode, the emitting diode, infrared diode. And the black one is the phototransistor. Okay, let's take a look. So the diode goes to the bottom part over here, and the positive should be facing towards the center of the keyboard. So it should go in like this. and it's supposed to be at the bottom. Okay, I think I made a mistake and I forgot to extend the canals over here. As usual, I had to overlook something. Yeah, so this one is still 1.2, which is... Okay, I extended this one, but I forgot about this one. That is not good. Okay, now it's kind of too late to do much about it. But it's not like we are out of options over here. We can still go back to the point 1. Yeah, I'm not gonna also reprint the right side just to be able to fit the wire. It's gonna be a waste of PLA, so I think I will just use the point 1 to connect the diode. It should be okay. Might be even easier and faster than using the normal wire. Although it is not the best if you want to push it through tight spaces because it's not really stiff enough, so it like bends everywhere. On this one we just need a tiny drop of solder because otherwise it won't fit into the hole. Okay, and another one. Alright, let's try to push it through. It would be nice if we also had the wires shorter for the ground one. Okay, so the longer one is the VCC, so we have to connect it over here. It has to go to this like from this resistor. Or maybe I should have put some more tin because the diode is a little bit wobbly right now. think I can finally solder it. Okay, and now the ground. I hope I didn't trim it too much. It would be nice to route it underneath those black wires. Okay, so over here we should have no problem. I've made a terrible blob. Well, we still have to fit in an encoder over here, so there'll be also a bunch of wires coming. Okay, this one, not quite sure at this point which one is longer. Let's say this one is longer. Okay, one is shorter, the other one is a little bit longer. So I think this should be more or less enough. Yeah, so I think putting a little bit more tin is a good choice. This one really went in, and it's yeah, it's not really moving at all. The other one is a little bit wobbly, so yeah, I guess I should have used more tin. Now it's too late. It doesn't look like it's gonna fall off. Okay, actually the length of the wire doesn't really make that much of a difference, because this one, we know already that this one is the positive one because it's facing the center of the keyboard, and the outer ones are the ground. So yeah, so this one goes to here. So as you can see, this is the collector. We have pull up from this resistor to VCC, and this leg will go to, we already have connected this leg to B5, so all we need to do is to connect to the transistor, and that should be it. I think I will expose this part a little bit more. Make it something more like this, so it will be easier to see all the wires. Okay, let's try soldering it. Okay, and the ground, I think we can move it all the way up here. Seems like it would be useful if we had one more 1mm wire bus like here for VCC somewhere, for the ground, maybe somewhere over here, because I am connecting everything to here. It's a mess right now. It's okay if we have only one wire coming, like from the switch, so that is only one connection, and it's okay. But when you have something like here that we have like multiple wires, then it's not that great. And like this part is actually where it would be the most useful, because we have like 1-2 grounds from here, from the diode. Then there will be one ground coming, 2 grounds actually coming from the encoder. Although for the encoder we can hook them up together, so that should be okay, I suppose. It might be difficult to pull off. Okay, so with that out of the way, I think we have infrared fully connected. We have VCC, we have all the grounds. We are wired to B5 over here, which is our input. We have the potentiometer as well. So fingers crossed that I didn't mess up polarity anywhere and it won't burn, or that it will still work when we connect. Otherwise we have to like rip it off and install a new one. Okay, so I guess next one we can do encoder. And I think this one will be the first time on the channel. Okay, so we have encoder, we have the wheel. What we're gonna be needing more? We're gonna be needing a switch, bearing, and a metal pin. Okay, so switch. No, sorry, no switch, okay. No switch because that's the horizontal one. So we're gonna be needing a bearing. Let me go and look for the metal pins. I was pretty much sure I had them somewhere over here, but they vanished like most of other stuff. I'll be right back. Well, I'm pretty much sure I had a full bag of the exact size that we need, 3 by 6. Ah yeah, indeed. Such a tiny bag. Okay, 3 by 6 should be good. Okay, so we take the bearing, push it inside over here. It should fit in. Like so. Then we take the metal pin, this one should go in as well, so we have something like this. So the wheel is ready, and now we need an I2C, not I2C, we need a encoder. I have some remaining ones from the previous build, so I'm just gonna use this one. Save some time on soldering the wires. I think this, yeah, but this is not gonna be long enough. Okay, so it doesn't matter. I have to take a new one anyway. This one goes back. So first thing, we have to cut this. Okay, then we're gonna be needing some wire for this one. You can use just black if you're okay, but I prefer color, so then we will know which one is what. I think this one will be common from the first one from the left. So this one is common pin, so ground should be connected over here. So technically you can make it black, and this one will be B and this one will be A. Let's double check. Yeah, exactly. So first one, this one is common pin, then we have B, and then we'll have A. Okay, so for the common one, I will use just black wire, and we don't really need it to be too long because we'll be connecting straight to the ground, which is not that far away. Although actually we don't even... Maybe we can get away with the metal wire. Yeah, I think it should make sense. Let me think about it. Is there a risk that it might desolder if we try soldering from the bottom? Would it be better to have the wire? Okay, I guess I will stick to the normal wire. Take a look. So from here we need to connect to here, so don't really need that much. This should be enough. Let's take a wire for the two remaining ones. Okay, so this one will be for B. I didn't have a blue one, and this one looks blue to me. And the yellow one will be A. And we have to solder to the back side of the encoder. Okay, so this one will be common. Okay, we have a good fit. Then the B. Okay. Looks like it's holding okay, and the last one will be A. Okay, this one looks good as well. Alright, so now we have to put everything together. Okay, how do I want it to be? Okay, so for this side, I want the bearing to be on the inside. Okay, messed up. Okay, so we are almost there. So the last thing is the wheel together with the bearing and the metal pin. Slide it like this. And then it goes like this. Nice. And it's done. Seems to be okay. The wheel is moving, there is no friction. Alright. I have to admit this is way easier than operating with the original one. That one was such a pain to solder anything. And this one is quite nice. Yeah. No issues. Sits nicely. Okay, so let's try solder it. Okay, so the ground, as usual, we'll just clamp everything together over here. Although we can move it somewhere else. So it's at less crowded, let's say maybe over here. Yeah, I think I will add one more 1mm pin over here. So we can attach all the grounds over here as well. That will be much more convenient in my opinion. Alrighty. Can we connect to here? Okay, so let's take a look on the schematic. So we are currently over here. Okay, at this point, I don't know which one will be what. This is A, and this is B, or maybe vice versa. Okay, let's follow. So B3 is like the lower number, so let's make it A, and before is the bigger number, so let's make it A. Let's make it B. But also, if we take a look over here, is there any Okay, there is no schematic. Like, how does the wave look like? Okay, so I'm gonna stick to that. So B3 will be A and B4 will be B. Although I have a sensation that it will be the other way around. So if I connect it like that, if I connect B3 to A and B4 to B, then if I scroll up, then it might be down, scrolling down actually. But we can fix it in firmware later. But what matters the most is to have like a ground ground assumption, like, okay, B3 will be A and B4 will be B. So if you do it on both halves the same way, then we can, if it's not the right way as we need it, we can always fix it in firmware later on. So that's not a problem. Okay, so first one, this is our B, this color. And the question is, should I push myself through here, or maybe I should go somehow around, or maybe from here? Let's see. Maybe I will go from the top, even though I said I would like to avoid that, but if I give it like a little bit more space, so then if I need to desolder the A ones, so I can always move this wire left or right. I think I will give it a little even more space. Okay, I think I will move it underneath. Okay, so let's trim it, maybe somewhere over here. Okay, I'm gonna put some tin for A4 and A3, so that will be for the next one. Okay, so we have B4 soldered in. So now let's do A3. That will be our A. All right. This one is so much easier than the original encoder. That one was really, really painful. All right. So we are left with only this one. And the mini jack as well. But the jack I always solder in the last, so we're gonna leave it for the, most probably both of these we'll do in the next stream because we are running low on time already. And like already half of the stream is not without any voice, so I guess that's not that much of a value in it anyway. All right. Okay, so far it looks okay. I am kind of satisfied. It's getting more and more crowded. Like we have a lot of wires everywhere. Yeah, I think there are still some fix-ups that we should do in CAD, like add this ground wire on the right side. Yeah, but overall, I think it looks okay. Yeah, kind of fine. Alrighty, for today, thank you very much for watching. Apologies for the no sound for the first 1 hour. I guess I'm gonna clip it. And that's it. Yeah. As for the Wednesday stream, I think it's still on schedule. So please do come back on Wednesday. I promise there will be voice and maybe the music as well, unless I get a warning from YouTube. Anyways, thank you very much for watching. I hope you enjoyed it. Have a good rest and please come back on Wednesday. Bye bye. Thanks for watching.